Hi friends, in this video I am going to solve the maxima and minima of a function with respect to the relation, or we can say the constraint. So here sometimes they will ask find the maxima and minima of a function with respect to the constraint. Let's say this is my function f of x comma y comma z in three variable x, y and z. So here these three variables are connected by some relation. Let's say phi of x comma y comma z. So here, find the maxima and minima with respect to this constraint. So here that is called maxima and minima, constraint maxima and constraint minima, or we can say constraint extrema of your function. So here in this with respect to this constraint, we can here eliminate one variable, say z, from with the help of this constraint. So here how to eliminate, and then find the here with respect to this constraint. We can use this constraint to eliminate one variable from your function, let's say z, and convert your function of three variable into the function of two variable, let's say f of x comma y. Then find the maxima and minima of this function by using the working rule of maxima and minima of function in two variable. Now here I will use the same method, how to convert the function of three variable into two variable with respect to this constraint. So here for example, let's say this is my function. So here given information, let's say given, here I want to write the answer for question 1. Given f of x comma y comma z which is equal to, so here x square plus y square plus z square with condition. So here with respect to, with condition, with let's say relation, with relation x plus y plus z which is equal to 3 times a. Now I want to use this constraint to remove the one variable z from your function to convert the function of three variable into two variable. Let's say here from here this implies z equal to 3a minus x minus y. Therefore function becomes, therefore f of x comma here, and remove z here. I am writing only xy because z is not there now, which is equal to x square plus y square, and in place of z square here I am writing this is 3a minus x minus y whole square. Now instead of finding this maxima and minimum of this function, now I want to find the maxima and minimum of this function with respect to this constraint. Now here, so step 1 for maxima and minima, step 1. So first we have to solve dou f by dou x which is equal to 0 and dou f by dou y equal to 0. So with the help of this dou f by dou x and dou f by dou y equal to 0, we get the critical point of your function, or we can say the stationary point of your function. Now how to find is the following: dou f by dou x which is equal to, so here 2x, so here 2x plus 2 times 3a minus x minus y into minus 1 which is equal to 0. So here derivative, partial derivatives 2x plus 2 times 3a minus x minus y, 2 minus 1 1, and derivative of 3a minus x minus y 0 minus 1 0. So minus 1 equal to 0. So this implies 2x plus, so here this is minus, so plus into minus becomes minus. So here 2 times this is 3a minus x minus y which is equal to 0. This implies 2x, just multiply, this is minus 6a minus minus plus 2x plus 2y which is equal to 0. Therefore 2x plus 2x, this is 4x plus 2 times y which is equal to 6 times a. This implies 2x plus y which is equal to 3 times a. Let's say this is my equation number, let's say this is my equation number 2. So here you can take equation number, so I will consider this as my equation number 1. Now in the same way I want to solve dou f by dou y equal to 0. So here dou f by dou y equal to 0. Now I want to find dou f by dou y equal to 0. Therefore, so which is equal to, so here dou f by dou y equal to, so here 2 times y plus 2 times 3a minus x minus y into minus 1 which is equal to 0. This implies 2y minus 2 times 3a minus x minus y which is equal to 0. 2y minus 6 times a plus 2x plus 2y which is equal to 0. This implies 4y plus 2x equal to 6 times a. This implies 2y plus x, which is equal to 3 times a. Let's say this is my equation number 3. Now from this here, from this therefore this is equal to x equal to 3 times a, x equal to 3 times a minus 2 times y. Therefore here from this I will write this is x equal to 3 times a minus 2 times y. Let's say this is my equation number 3. Now therefore equation 2 becomes, therefore here equation here 2 becomes, equation 2 becomes, so here this is 2 times the value of x is, so here value of x is 3 times a minus 2 times y plus y, which is equal to 3 times a. Therefore here this is 6 times a plus minus 4 times y plus y, which is equal to 3 times a. This is 6 times a minus 3 times y, which is equal to 3 times a minus 3 times y, which is equal to 3 times a minus 6 times a. Therefore minus 3 times y, which is equal to minus 3 times a. Therefore y equal to a. So minus minus cancel, 3 gets cancelled. This is the value of my y. So just put the value of y in equation 3. Therefore equation here 3 becomes, equation 3 becomes x equal to, just put 3a, put the value of y as a minus 2 times a, which is equal to a. So therefore the value of x is a and the value here, therefore x equal to a. Therefore the value of x equal to a and y equal to a. This is my stationary point, or we can say the critical point of my function. Therefore a comma a are the stationary point of f of x comma y. Now I want to find the nature of my function at this point, whether my function is maximum or function has maxima or minima at this point a comma a. Now I want to find maxima and minima of my function at this point. Now here this is my dou f by dou x, this is my dou f by dou y. Now I want to find dou 2f by dou x square, dou 2f by dou y square, and dou 2f by dou x dou y. So here please pause and write. I don't have space. Here this is dou f by dou x. I want to find dou 2f by dou x square with the help of this, and dou 2f by dou y square with the help of this. That's why here I want to rub this part. So please, I want all of you write. So now here I want to find RST, means here now find R equal to dou 2f by dou x square and S equal to dou 2f by dou x dou y and T equal to dou 2f by dou y square. I want to find these three quantity: R dou 2f by dou x square, S dou 2f by dou x dou y, and T equal to dou 2f by dou y square. So here this represent. So here now I want to find. So this is the curvature along the x direction, curvature along the y direction, and this is curvature along the this is the twisting of my surface along the x and y direction. So here no need to discuss this. So now tell me, so how to find dou R equal to dou 2f by dou x square, which is equal to, so here now I want to find dou 2f by dou x square. So let's say this is my dou f by dou x. So here this is here 2 times yes, this is 2 times x. The partial derivative, let's say here this is 2 times x. So here this is simply 2. Here minus 2 times. Here partial derivative of 3 is 0. This is minus 1. So here this is minus 1, which is equal to 2 plus 2, which is equal to 4. Therefore this is R equal to dou 2f by dou x square. In the same way I want to find S equal to, here partial derivative of this function with respect to y. So here dou 2f by dou x is this. So here dou 2f by dou x is this. I want to find dou 2f by, here I want to find dou 2f by dou x into dou y. Again I want to partially differentiate this function with respect to y. So here this is constant 0. So here minus 2 times. So here minus 2 times. This is 0. This is 0, and this is minus 1. So this is minus 1, which is equal to, so here minus minus becomes plus. So this is 2. So here my S is 2. Therefore now I want to find T equal to dou 2f by dou y square, which is equal to, now here dou 2f by dou y square. So here 2, So here this is 2 minus 2 in bracket. So here this is minus 1. So here this is minus 1 which is equal to 2 plus 2 which is equal to 4. So here this is my r, that dou 2f by dou x constant. This is my s 2 and this is my t equal to 4. Therefore at a comma a, so all functions are constant. So here any point value of r is 4, s is 2 and t is 4. At a comma a, r equal to 4, s equal to 2 and t equal to 4. Therefore rt minus s square equal to, so here r equal to, here 4 minus 2 square which is equal to 16 minus 4 which is equal to 12 which is strictly greater than 0, and rt minus s square is greater than 0 and r equal to 4 which is strictly greater than 0. Whenever rt minus s square is greater than 0 and r is greater than 0, at that time your function has minima. Therefore function has minima with minimum, the function has minima at a comma a with minimum value. So here with minimum value at a comma a which is equal to, now tell me, just put a at x. So here where is your function? So here this is my function, x square a square plus y square a square plus 3 times, here 3 times a minus a, this is minus a whole square which is equal to 2a square plus 3a minus 2a, this is simple a square which is equal to 3 times a square. So here this is the minimum value of my function at a comma a. So now, so here example 2 says, so here given f of x comma y comma z which is equal to x cube y square z with condition. So here with respect to condition, with condition, or we can say relation, x plus y plus z equal to 1. So here which this implies, so z equal to 1 minus x minus y. Now I want to put the value of z in this function to convert the function of 3 variable into 2 variable. Therefore f of x comma y which is equal to x cube y square 1 minus x minus y. So this is my function. Now let's say this is my equation number, equation number 1. Now I want to find the maxima and minima of this function by using test. So here let's say solve step 1, solve dou f by dou x equal to 0 and dou f by dou y equal to 0 to find the stationary point of your function. So this to find the stationary point of your function. So here dou f by dou x equal to, so here dou f by dou x equal to, first write, so don't use the product formula. So here I want to just multiply, which is equal to x cube y square minus x to the power 4 y square minus x cube y cube. So here x cube y square minus x to the power 4 y square minus x cube y cube. So let's say this is my function f of x comma y. I don't want to use the derivative product rule. So here let's say this is equation number 1. Now step 1 says solve dou f by dou x equal to 0 and dou f by dou y equal to 0. Now here with the help of this 2 you will get the stationary point of your function. So here to find the stationary point, dou f by dou x equal to, so here this is 3x square y square and minus 4x cube y square partial derivative with respect to x, keeping y as a constant. So derivative of x cube is 3x square, y as it is x power 4, 4x cube y square as it is minus 3x square y cube which is equal to 0. Now just observe one thing. So here this is x square, this is x square, this is x cube. Take x cube common and here y square is the minimum. So here you can take 3 not allowed. So here x square and y square, we can take x square and y square common. So here 3 minus 4x, this is here this is minus 3 and y which is equal to 0. So this implies x equal to 0 or y equal to 0. So here this implies, so I will write x equal to 0, y equal to 0, and so here I will write 4x minus 3y. So 4x minus 3y, so minus 4x minus 3y which is equal to minus 4. This implies, so here I will write directly 4x plus 3y equal to 4. So here in place of that, here I want to write 4x plus 3y which is equal to 3. Let's say this is my value. So here I will take, this is a, just for the sake of understanding. So here this is the pair of 3 equation is a. Now dou f by dou y. I want to find dou f by dou y. Here dou f by dou y. So this is 2 times x cube y square, y minus so here minus, this is 2 times y x power 4, this is minus 3 times x cube y square which is equal to 0. Now from here I will take x and y common. So here this implies, here I will take x and y common. So therefore this is x square. Yes, this is here you can take x cube common. So here x cube. So here y, this is 2 times minus 2 minus, this is x cube means x. This is 2 times x. 2 times x, here y is common, minus 3 times. So here x is taken common. So this is y, one more y which is equal to 0. So from here x equal to 0, y equal to 0, and here 2x plus 3y which is equal to 2. Let's say this is b, the pair of equation with b. Now just observe one thing. Now I want to take from the pair of equation a and pair of equation b. So here I want to take the pairs. So here x is 0, here y, x is 0 not many, x is 0, y is 0. So here from a and b, so from a and b, so from a and b, x equal to 0, here y equal to 0 from b. Here x equal to 0, y equal to 0, x equal to 0, this equal to 0, x equal to 0, here x equal to 0, and 2x, here 2x plus 3y equal to 2. Now y equal to 0, and here this is x equal to 0. So here y equal to 0, this implies here y equal to 0, this is x equal to 0. Now y equal to 0 and this equal to 0. So here y equal to 0, and with this 2x plus 3y which is equal to 2. Now with respect to this 4x plus 3y equal to 3, x equal to 0. Therefore 4x plus 3y equal to 3 here, and this is x equal to 0. Here this is 4x plus 3y equal to 3 and y equal to 0. 4x plus 3y equal to 3, and this is 2x plus 3y equal to 2. Therefore you will get 3 pair, and this is one more, when x is 0, this is y is 0, and x is 0, this is 1, y is 0, y is 0, x is 0. Now here same thing, not allowed. Here x is 0, y is 0, this is same. Now here y is 0, x is 0 is 1, y is 0, y is 0 is not given, y is 0, this is 1, 3x is 0, this is 0, 4x plus 3y equal to 3, and x is 0, 4x plus 3y equal to 3, y is 0, and this. Okay, so here these are the 4 pairs. So here x is 0, this is 0. Now let's say this is my here Roman, so let's say this is my Roman 1, let's say this is my Roman 2, let's say this is my Roman 3, let's say this is my Roman 4, let's say this is my Roman 5, and let's say this is my Roman 6. Now from 1, so here from Roman 1 I got the one pair, sorry, 0 comma, so 0 comma 0. From Roman 2, so now when x equal to 0, when x equal to 0, if I put x equal to 0 here, 3y equal to 2, therefore y equal to 2 by 3. So here x equal to 0, y equal to 2 by 3, y equal to 2 by 3. So this is my one pair. Let's say from let's say Roman 3, from Roman 3. So here you will get when y equal to 0, so put y equal to 0, x equal to, so here from Roman 3 y equal to 0, 2x equal to 2, x equal to 1. Therefore x equal to 1, comma y equal to 0. And from Roman 4, when x equal to 0, when if I put x equal to 0, y equal to 1. Therefore x equal to 0, y equal to 1. Now from Roman 5, from Roman 5, when y equal to 0, put y equal to 0, x equal to 3 by 4. So here x equal to 3 by 4 and y equal to 0. And from 6, so here from 6 here, from Roman 6, when so here you want to solve this two equation, 4x plus 3y equal to 3 and 2x plus 3y equal to 2. So here I don't have space, here I want to, so here I will solve, here after that I will write the value. So here 4x, here 4x plus 3y equal to 3 and 2x plus 3y equal to 2. So here just subtract equation, so this, let's say this from, just subtract this, you will get 2x equal to, so here this is 0, 2x equal to, this is 3 minus 2 is 1, therefore x equal to 1 by 2. If x equal to 1 by 2, put this here, x equal to 1 by 2, 4 by 2 plus 3 times y, which is equal to 3, 3 times y equal to, so this is 2, 3 minus 2, y equal to 1 by 3, y equal to 1 by 3, x equal to 1 by 2. So here y equal, x equal to, so 1 by 2 and y equal to 1 by 3. This is my one pair. So with the help of this 6. Now here these are the 6 critical points. So here these are the 6 stationary points of my function. Now I want to check the nature of my function at each and every point. So here let's say this is P, Q, R, S, T, and this is U. Now I want to find the nature of my function as P, Q, R, S, T, U. So at this 6 point, for that purpose I want to find R, S, T. So here, but I don't have space. That is also important. Now here this is here I will write my function. Here I will write my value of my here. Now let's say R equal to dou to f by dou x square, which is equal to, so here dou f by dou x is this. So here dou f by dou x equal to this. I want to find dou to f by dou x square. So here how to find? So if this is my dou f by dou x, if this is my dou f by dou x, now partial derivative of this function with respect to x again. So here this is equal to, here 6x y square minus, so here 4x cube y square, this is, so 4x cube y square, this is 12 times x square y square. So here 6x y square, this is 12 times x y square, and this is minus 6x times y cube, minus 6x times y cube. Now this is my dou to f by dou x square. In the same way, I want to find dou to f by dou y square. So here I want, now first I will find s. S equal to dou to f by dou x dou y. I want to find, this is my dou f by dou x. I want to find partial derivative of this function with respect to y. This becomes dou to f by dou x dou y. So here partial derivative of this function with respect to y. So here this is 6 times 6x square y minus here 8 times, here minus 8 times x to the power 3 y minus, this is minus 9 x square y square. Now this is my yes, dou 2 f by dou x dou y, and now I want to find t equal to dou 2 f by dou y square, which is equal to, so here this is my dou 2 f by dou y, so here dou 2 f by dou y square, so here this is 2x cube minus here minus 2x to the power 4, so this is minus 6 here, minus 6 x cube and y. Now this is my r, this is my s, and this is my t. Now I want to check the nature of my function at each and every point. So at 0 0, so here 0 0, so here now at p that is 0 comma 0, so here p 0 comma 0, at p r equal to, so here just put x and y both are 0, so at r is 0, s equal to, so here x y, so therefore 0, and t equal to 0. Then therefore rt minus s square equal to, so here 0 into 0 minus 0 square, which is equal to 0 minus 0, which is equal to 0. So here rt minus s square equal to 0, at that time test fail. So here therefore at p test, here test fail. Now I want to find at q the nature. So here now I don't want this. Now at q is here 0 comma 2 by 3, here 0 comma 2 by 3, find rst. So here r equal to, so here put x equal to 0 and y equal to 2 by 3. So here if I put x equal to 0, so here this complete term 0 into anything 0, 0 into anything 0, 0 into anything 0, 0, and s equal to, so here if I put x equal to 0, complete term is 0, therefore s is 0, and t equal to, so if I put x equal to, if I put x equal to 0, this is 0, this is 0, this is 0, therefore 0, therefore at, so here therefore at here, therefore rt minus s square, rt minus s square equal to 0 0 minus 0 square, which is equal to 0 minus 0, which is equal to 0. Therefore at q, that is 0 by 0 comma 2 by 3, test fail, test fail, or we can say no conclusion. Now at r, r is 1 comma 0, that is x is 1 and y is 0, therefore x is 1. Here r equal to, here x is 1, y is 0, but 0 into anything 0, x is 1, y is 0 0, x is 1, y is 0 0, here complete r is 0, s equal to, here x is 1, y is 0 0, x 1, y 0 0 0, and t equal to, so here x is 1, y is 0, so this is 2 minus, so here 2 minus 2, and so this is complete 0, which is equal to 0. Therefore again rt minus s square equal to 0 0 minus 0 square, which is equal to 0 minus 0, which is equal to 0. Therefore at r, that is 1 comma 0, test fail, or we can say no conclusion. Now in the same way I want to find at here this is r, at s, so here at s, so here at s, which is 0 comma 1, so here x is 0 and y is 1, x is 0, this is 1, sorry, this is 0, this is 0, this is 0, therefore r equal to 0, here x is 0, y is 1, 0 0 0, s equal to 0, here x is 0 0, complete term is 0, therefore here r is 0, here s is 0 and t is 0, therefore again rt minus s square equal to 0 into 0 minus 0 square, which is equal to 0. Therefore at here 0 comma 1, again no conclusion, or test fail. Now I want to check at So this S is over. I want to take check at T and U. So here this part is over. Now I want to check at T and U. So please pause and write, or no need to write this. Just read, but try to understand what is going on. Now at T. So here at T, that is 3 by 4 comma 0. 3 by 4 comma 0. So here y is 0. So here r equal to, if y is 0, this is 0, 0, r is 0, and s equal to, so here y is 0, 0, complete 0, and t equal to, so here now at t equal to 3 by 4, we have to check here r equal to 0, s equal to 0, and t equal to, so here 2 times, so therefore x is 3 by 4, 3 to the power cube by 4 cube minus 2 times here 3 to the power 4 by 4 to the power 4. So here which is equal to, so here 2 into 3 cube is 27 divided by, this is 4 cube. So here 4 into 4 into 4. So here 16, this is 64. So here minus 2 times, this is 3 to the power 4 is 81 divided by, this is 256, which is equal to, so which is equal to 54 divided by 64 minus, so this is 81. So here 81 divided by, I will write this as 128. So here 128. So which is equal to 64 into 2. 64 into 2 are here 64 into 2, 8, 12. So here I want to multiply numerator by 2. So which is equal to 54 into 2. This is 8, 108. So here which is equal to 108 divided by 128 minus 81 divided by 128. Now 108 minus 81. So here 7. 7. 8 minus 1, 7. Here 0, that is 10 minus 8 is 2. Therefore which is equal to 27 by 128. So here this is my t. Therefore here, therefore r t minus s square equal to, so here r is here 0 and t is here 27 by 128 minus 0 square, which is equal to 0 minus 0, which is equal to 0. Therefore at 3 by 4 comma 0 also, here function test failed. At function neither has minimum rt minus s square equal to 0, that part, so test failed. So here this is test failed. Now I want to check at last point 1 by 2 comma 1 by 3. Now here I will check at u equal to this point. So here please pause and write, which is equal to, now at u, so the coordinates are 1 comma 2, 1 comma 3. Therefore r equal to, here r equal to 6 times x is 1 by 2. So here 1 by 2 into 1 by 3 square, 1 by 9 minus 12 times 1 by 4 into 1 by 9 minus 6 times 1 by 2 into 1 by 3 cube, that is 27. So here which is equal to, so here this is 2 6 are 3, 3 here 9. Therefore this is simply 1 by 3. So here 2 से अगर 6, 3 से अगर 1 by 9 minus, so here 4 3s are 12, 3 into 3 1 by, so here this is 3, so again 1 by 3 minus, so here this is 3 and 3 9, so here minus 1 by 9. So here this is 0 and this is minus 1 by 9. So r is minus 1 by 9. I want to find yes. Yes equal to, now here yes equal to, therefore yes equal to at 1 by 2 comma 1 by 3. So here 6 times, here 1 by 4, 6 times 1 by 4 into 1 by 3 minus 8 times 1 by 8 into 1 by 3 minus 9 times 1 by 4 into 1 by 9. So here which is equal to 3, this is 2, 2, 2. So here 1 by 2 minus 8, 8 gets cancelled, 1 by 3 minus 9, 9 gets cancelled, this is 1 by 4 which is equal to, so here this is equal to 3 minus 2 by 6 minus 1 by 4 which is equal to 1 by 6 minus 1 by 4 which is equal to 4 minus 6 by 24 which is equal to minus 2 by 24 which is equal to minus 1 by 12. Now I want to find t, therefore t equal to, so here 2 times 1 by 2 cube 1 by 8 minus 2 times 1 by 2 to the power 4. So here 2 into 2 into 2 into 2. So here 4, 8, 16. So 16 minus 6 times 1 by 8 and 1 by, this is 3 which is equal to here 1 by 4 minus 1 by 8 minus, this is 6 into, this is 2, this is 2, 4, this is minus 1 by 8. So here plus minus 1 by 4, this is minus 1 by 8. Therefore t equal to minus 1 by 8. Now I want to find RT minus s square equal to, so here R is, where is R? R is minus 1 by 9 and RT, T is my minus 1 by 8 minus s square. S square is minus 1, minus 12 whole square which is equal to, here minus minus plus by 72 minus 1 by 144 which is equal to, now 74 into 2. So here just 2 by 144 minus 1 by 144 which is equal to 2 minus 1 by 144 which is equal to 1 by 44. So which is greater than 0, that is RT minus s square is greater than 0, and you can check R equal to, so here R equal to minus 1 by 9 which is less than 0. Therefore function has maxima at 1 by 2 comma 1 by 3. So I think this is the okay, this is the therefore function has maxima at 1 by 2 comma 1 by 3 with maximum value. So we have to find the maximum value of your function at this point. So here how to find here. So tell me the function. Here the function is f of x comma y equal to x cube y square into here x cube y square 1 minus, so here 1 minus x minus y. So here at 1 by 2 comma 1 by 3, that is maximum of your function at 1 by 2 comma 1 by 3 which is equal to 1 by 8 1 by 9 in bracket 1 minus, this is 1 by 2 minus 1 by 3 which is equal to, so here this is 1 by 72, here 1, this is 1 by 2 minus 1 by 3 which is equal to 72, which is equal to 1 by 72, here 1 by 72, here 3 minus 2 by 6 which is equal to 1 by 72 into 1 by 6. Therefore 72 into 6, 6 2s are, so this is 2, so this is equal to okay, so this is equal to 1 by 4 3 2. Yes, the maximum of your function at 1 by 2 comma 1 by 3 equal to this. So here 72 into 6 is this, 6 2s are 12, 6 into 7 42 plus 1 so 43 2. So therefore 1 by 4 32. So this is the maximum value of your function at 1 by 2 comma 1 by 3 in this way. So this is the way to solve the maxima and minima of your function with respect to the constant. Here with respect to constant, so first convert, so this is your function and which is your constant. First write the function and with the help of constant remove the one variable from with the help of your constraint, remove the one variable from function. Try to convert the function of 3 variable to 2 variable. Then use the maxima minima method of your function of 2 variable and whatever. So here first find the stationary point with the help of the stationary point. So find the nature of your function by using RST at that critical point. So here in this way you can solve. So this is the problem. So thank you.